Hello and good evening, my fellow elements and all other guests. I am your host, Silver, and I welcome you all to our talent show this evening. In the first row, you will see our lovely judges. Very inert, Miss Helium, Mr. Neon, Miss Argon, Mr. Xenon, and Mr. Krypton. Don't bother talking to them, they don't react much. So, with no further ado, let's start the show. Let's call our first contestant, Sodium and Chlorine. Hello, everyone. Today we are going to juggle our electrons. Um, we are sorry, that's it. That was some nice bond. Up next, we have a group of gymnasts. Our favorite oxygens and hydrogen. Brilliant, brilliant. Up next, we have a cute oxygen fashion show. Let's have a round of applause for them. Let's get the scores now. Seems like the judges have a very neutral view on our competitors. Well then, everybody wins. That was a beautiful evening. Thank you all for coming. See you soon. Take care. Good night. Well, students, that was really a unique show, wasn't it? I wish we also could have similar shows. Hello students, welcome to another video of Notebook. Seeing all those atoms taking part in a competition, I hope you've already started guessing the chapter. Yes, today we are going to enter into the world of atoms and molecules. In this part of the chapter, we will discuss just the first topic as you can see in this flowchart. So let us first understand what matter is. All substances around us are made up of matter. Matter is anything that possesses mass and occupies some space. Do you know that ancient Indian and Greek philosophers wondered about the basic form of matter, which was at that time unknown to them? Then Maharishi Kannad first postulated that if we divide matter into smaller and smaller parts, a stage will be reached beyond which the particle won't be divisible any further. He named this stage Parmanu. The term atom was introduced by the Greek philosopher Democritus to define these indivisible small particles. Students, with that brief history of atoms, let us try understanding about them more. So, what exactly is an atom? An atom is the basic building block of matter. Let us think of a simple brick wall. As you must have seen, they are made by a repeated and regular arrangement of bricks. Similarly, the cells in the body of a living organism are arranged in a regular systematic fashion. Now let us take a closer look at an iron block. Closer and magnified inspection will reveal that the iron block is actually made up of iron atoms arranged in an orderly fashion to form the block. Students, do you know that an atom is extremely small in size, in the order of nanometer? Hydrogen atom is the smallest atom, having the radius of the order of 0.037 into 10 to the power minus 10 m or 0.37 nm. Atoms consist of three fundamental particles, namely electron, neutron and proton. Proton and neutron are placed at the center of the atom known as nucleus, and the electrons revolve around it in different orbits. The number of protons present in the nucleus is the atomic number, while the sum of the number of protons and the neutrons is the mass number. The atomic number is always different for different elements. After that introduction and understanding on the structure of atoms, it is time for us to learn about one of the greatest scientists of his time and his postulates, John Dalton. John Dalton was an English chemist, physicist and meteorologist who was born in 1766. He is famous for his introduction of atomic theory, which is better known as Dalton's atomic theory of matter. Dalton's atomic theory had a number of postulates. Let us learn them one by one. The first postulate states that the matter is made up of very small particles known as atoms, which are indivisible. According to the second postulate, atoms can neither be created nor be destroyed. The third postulate states all the atoms of a particular element are same, having identical size, mass, chemical properties, and so on. According to the fourth postulate, atoms of different elements have different sizes, masses, and chemical properties. The fifth postulate states that atoms of two or more elements join together in chemical combination to form compound molecules. The sixth and the final postulate states during chemical combination, atoms of different elements do combine in simple whole number ratios. Like all theories, this theory too had its share of merits and demerits. Let us learn about them now. The merits of the Dalton's atomic theory are: it could explain the existing laws and predict the law of multiple proportion. Secondly, it has proposed the concept of atomic mass. Thirdly, it enabled the explanation of the laws of chemical combination. As with merits, it also had its demerits. Let us see what those are. With modern developments in chemistry, it was found that atoms are not indivisible and are composed of electrons, protons, and neutrons. According to Dalton's theory, all atoms of same element have same mass, while it's now known to science that same elements may have different masses known as isotopes. This was the second demerit. Thirdly, it is seen that atoms of different elements may have same masses, which violates one of his postulates. For example, argon, potassium, and calcium have same mass number, while their atomic numbers are 18, 19, and 20 respectively. So students, you saw how we learned so many different things about atoms today, and I think it's too overwhelming for you guys now. We will learn about the rest in our next videos on this chapter. We hope to see you soon. Till then, happy learning and goodbye.